Thank you for joining me back here today, and we're going to talk about the second most crucial thing when it comes to sound engineering or any kind of live stage setup. And as we talked about the first most important thing, which is your inputs, uh, and that was microphones we discussed in episode 1. But here in episode 6, we're going to talk about the second, and you probably already guessed, that is your outputs. So anything that is coming out of all the sound that you're capturing. So when you're looking at outputs on a live stage setting, like you have different outputs for recorded applications, you have different outputs for projected audio applications like live stage performance. And that's generally through PA speakers, professional stage speakers. And that's different actually than the speakers you would see in like a home theater system or computer desktop speakers. So the difference between the two generally is one is the size. You don't really find a huge, massive PA speaker in like a home desktop computer setup or home theater. So size is one factor, and we're going to talk about the reasons why different PA speakers or different speakers generally have different sizes and the purpose for that. So in a home theater system, like I said, there's or a computer desktop system. The two difference between professional speakers and consumer speakers is not just the size generally, but also the wattage. Wattage referring to electricity, the type of, not the type, but how much power is coming in and being consumed and used for those speakers to project sound pressure decibel. And that's, we're going to talk a little bit about that later in a future episode, because I haven't really touched on SPDB, which is sound pressure decibel. And basically that is what sound is. If you hear like the term sound, sound is referred to as sound pressure decibel. That's the technical term for it. So I'm going to go in a future video, talk about and break that down, why it's called sound pressure decibel. But you're going to get a little introduction of that in this because we're talking about projected audio and how that sound is being produced. So there is some understanding about sound pressure decibel when it comes to the size of the PA speaker and how that sound pressure changes depending on the size of the speaker. So I'm going to touch on all these things here today, but I'm going to make it very brief. Now, getting into this, I'm going to share my desktop. Okay, so opening this here, I went to Google and I searched for a PA speaker. So I'm just going to open up here one image on a link here. And you can see here generally, if I can zoom in, that this is a very small speaker. But this is supposed to be heavy duty PA speaker for like an environment or a room. Now, looking at the size of this speaker, the first thing a person would look at before they start purchasing a speaker is, okay, how many reviews does it have? And also, is this designed for, what's the brand name? And is it a reputable brand name? Because if it's a well-known brand name, then automatically it's going to be a good speaker. So those are two things that people generally look for when they're shopping, is the reviews and the brand. But that's not actually the most important thing that we should be looking at. And that's what I'm going to touch on the video here today. Because the most important thing that we need to look at when we're purchasing speakers are the same thing as I talked about when we talked about microphones for inputs. When you're looking at outputs, you need to know what size of room you're in, that you're going to be putting this in, and also what is the sound pressure decibel coming out of these speakers. Is it adequate? Because if it's not, then it's going to create sound distortion. So there's actually a reason based on the sound pressure decibel, and I'm going to explain that in the next slide. Before I jump into that, I don't want to get ahead of myself here. Let me go back to a previous image just to show you. Okay, so that's a small PA speaker, because I want you to have like a visual of the different speakers before I then talk about the differences between them. So that was a small PA speaker. And then you have one that's like medium size here. And these medium sized ones, you're now seeing something different here. You're seeing two drums inside of the speaker. You got a very small one up here, and then you got a larger drum down here, and this is a middle-sized speaker. So you might be wondering then, okay, well, why does the small PA speaker have a single drum, and now why, when you start getting bigger on the PA speakers, they start having more drums in them, and then some can actually have 3 or 4 or even up to 8. I've seen actually up to 8 drums inside of the speaker. So here's another one, and this one here has 1, 2, 3, 4. Okay, why would they have 4 of these drums to be in this speaker? And what difference does it make compared to, does the number of drums inside of the speaker change the sound? And is there any importance to how many drums are inside the speaker, and why are some small and some large? So now we're going to talk about the purpose of the drum and what the drum is and why it is the source of the sound pressure decibel, which creates the sound that you hear. So getting into that, we're going to go to the next slide here. And if you look at here, you got some other ones which are very, very large. So yeah, there's small, medium, and then large. So one factor is the wattage. You're looking at the wattage of the speaker, okay? And then you're looking at the size of the speaker, and then you're looking at how many drums are inside of the speaker. Now, out of these 3 things that I've just mentioned, what are the importance of them? I'm going to show you a visual demonstration of water and ripples inside of a water and how that is significant to the laws of sound. A small pebble or a small rock can't make a large ripple in the water. And when it's thrown too hard into that water and creates too much pressure, you can then splash and distort that ripple wave. If you had something large and dropped it into the water, it creates a different wave. And that's what I wanted to explain here. Because water, you can visually see water. And when something with pressure hits the water, you can see the wave of that water, that ripple. And when you see the ripple wave of the water, it's also how it works in sound space, but you don't see that visually. And that's why they call it sound waves, because it's the same as water waves, just in invisible, like air. Like, because air is invisible, right? We can't really see air. But when you have something with so much sound pressure impact the air, because air is actually, I don't want to get scientific about this, but air consists of something. I'll say it that way. Air consists of something, even though it looks invisible. And whether it's molecules, particles, and whatever you want to call it. But air has a bunch of stuff in it. Pollution, it has oxygen, it has... but the point is, air consists of something. And because there's a volume, it's a really low density volume in the air, and water is more dense. That's why you probably visually see it compared to air. And you know, if you have evaporated water, you don't really see that until it all gets formed together, and then you see clouds in the sky. But low density, which is air, consists of something, regardless whether you see it or not. There is something that air consists of. So when you have so much pressure impacting that mass or that volume, and you break, like you can create a wave, just like you see on water here. Like, I'll just show you a very clean example here. So with water, if you have a very small droplet of water touch the mass of water, just like pressure of something hitting the air, it will create like a ripple wave. And that's what happens when the speaker, the drum of the speaker, vibrates out and then in. It basically pushes the air. And you'll see it like bouncing in and out. Like if you look at like a car, and you see like if you had like an open drum subwoofer in the car, you can just even search like subwoofers or car speakers, and you can see some YouTube videos of how the speaker drum is vibrating when it's creating that sound. So basically it's pushing the mass of air, and it's creating a wave, just exactly as you see here with water, with a droplet. So when when a water droplet comes down and hits the mass of water, when that circular shape of the drum is now pushing outward, it's almost the same as a circular shape of water hitting the mass of water. When that circular shape of the drum of the PA speaker is popping out, it'll impact the air and create an invisible wave, which is called sound. So it does the exact same thing as you're seeing here with water. But the thing is, if you have a smaller drum, if a smaller droplet of water, smaller round circular shape, and tiny one, but if you notice, this round shape here is exactly the same circular round shape of the droplet of water that is now coming to hit the mass of water. So what happens here, like I said, this circular shape in the middle, when the drum, the outer shape of the drum, when it flexes because of pressure and it pops out, this little circle shape in the inside is going to pop out at very fast speed. And that fast speed impact is creating sound pressure, which is sound pressure decibel. So as it pops out in this little circle shape, and this is a bigger one, and you have a smaller one here, this smaller one is going to create a smaller ripple in the visible space of the air of sound. And this larger one here is going to create a larger ripple. So the size of ripples, you might be wondering, okay, does the size of ripple really matter? Yes, it does, because when you're looking at that ripple, based on the size of the ripple will determine which frequency that sound is. So a larger ripple is going to be on the lower frequency spectrum of sound, and a smaller ripple is going to be on the higher frequency spectrum of sound. So with that being said, understanding the size of ripple is important to know what sound is being produced. So if we understand that, we're going to see that, okay, this small droplet that's coming down, hitting the water, is creating a very nice clean ripple. But here's another thing. Okay, so a small droplet of water is able to create a small ripple for all the high frequencies of sound. And then it also spreads out to create lower frequencies of sound, the larger ripples, the more heavier waves. So with that, we can see that one small PA speaker, like we looked at the first part of this recording, is able to create, or able to produce, I'll put it that way, it's able to produce within the spectrum of sound the low frequencies and the high frequencies. This is why you're able to hear music which has a combination of low and high and mids in a single PA speaker. But on a professional stage, you'll notice that sometimes these all-in-one speakers, which can give you, like this water droplet you see, the small wave, the middle wave, and the large wave or larger wave, sometimes they can't give wave. See, look, if you look a little bit further where my mouse is moving, there's no waves here. Now, these waves are missing because it's a small droplet of water, which means that this ripple only extends to a certain point and then it starts fading out. So what if your bass guitar and your drum kick is sitting way out here in the frequency spectrum of wave, and you need that wave produced to be able to hear the heaviness, the boom, boom, boom of the drum and the bass? What are you going to do? You're going to need a larger drum size on the PA speaker to produce that lower frequency spectrum of sound. So this is why, if I go back to, you'll see that a PA subwoofer is just a single speaker with a giant barrel drum. And that's to create the massive wave that you see. And here's a double one here. So, and this is huge. This is like almost 5 feet, and it can be laid down this way or stood up straight. So with that, the larger droplet is important. But now what happens? I'm gonna visually explain a problem that happens with people that end up buying the wrong speaker for the wrong application. So before I get, sorry, I'm jumping ahead. So there's so much I want to talk about, and it's just great knowledge to have, visual knowledge. So we talked about small PA speakers, but then it's missing the larger waves. So you need, that's why if you see on a professional stage, they also have, like I showed you, a subwoofer on the stage to handle all the heavy bass in the room, and they have smaller speakers to be able to handle the rest of the spectrum of frequency of sound. So you will notice that even if you have good PA speakers in the room, you'll be missing that low end sound, that the bass guitar and the drum kick. That's why you'll add an additional subwoofer in the room on top of your PA speakers, because it's a PA speaker technically, but it's designed with only a large drum to produce only the low frequency spectrum. So that's why the big subwoofer will only create that boom boom sound, and it won't create anything else, because the size of the drum on it only pops out that large wave for the low frequencies. So this is basically what's happening when sound is being produced out of a PA speaker, but you don't visually see it. But I'm visually showing you here with water. So with that, here's a problem that generally happens when you take a small speaker and look at now. See what I showed you. Let me go back to this one. Do you see how it's missing the waves here on the outside? This little droplet of water, because it's probably just falling naturally. This means that the sound is probably at like normal volume, like maybe halfway, and you have a decent volume. But let's say if we want to take that dial on the PA speaker and we want to crank up the volume, what's going to happen? Right here. You're going to take that pressure and you're going to use the wattage, the electricity, the amplitude of the PA speaker. And that's why sometimes you'll have PA speakers that are only 18 watt all the way up to 350 watt, 400 watt, 800 watt, all the way up to 1,500 watt speakers. So you can have a very tiny speaker, like a computer desktop or a home theater speaker that's very small, but it's rated at 1,500 watt. So a 1,500 watt speaker compared to like a 50 watt speaker is going to have a way louder capability of producing sound, where it's going to be like a professional home theater sound system. So the wattage is very important when it comes to how loud the speaker is able to go. So that's one thing a lot of people don't know, is when they're looking at buying speakers, the wattage of the speaker will determine how loud that speaker is able to go, because the wattage is the electricity used to pop out that speaker at a faster rate and at a harder rate. And that's why they say if you turn the volume up too loud, you could end up popping your speaker, and then you basically break your speaker. So even though higher quality brand speakers that are rated at high watt capacity are able to handle this high sound pressure, therefore maintaining clean sound, but no matter how durable the quality of speaker or brand, there's always a risk to pop the drum with too much pressure. Better quality does have less risk, of course, hence which is why it may seem that smaller speakers can replace larger speakers and sound just as good, but if used to substitute a large speaker for intense workloads, you shorten its lifespan by cutting corners and could cost you in the long run. So they say don't crank up the volume too loud because you don't want to pop your speaker. That's where that term is coming from. So if you're looking at it here, this is what's visually happening when you have a very small speaker and you crank up the volume. So let's say you're in a large room, you want to save money, you don't want to spend $2,000 to $3,000 on a large PA speaker, and you want to go with a smaller speaker. And this is the thing, you can buy smaller, like I said, smaller speakers with a higher wattage. So you don't need to necessarily go with a larger speaker. And that's why some people say, well, smaller speakers can now produce really good sound compared to having to get a large speaker. The reason for that is because smaller speakers can have higher wattage. Yes, that's true. But there's some negative side to it that I'm going to explain here. Because even though you can get a smaller PA speaker with a larger electricity capacity wattage to produce louder sound, a higher quality small speaker, it's possible to do that. But this is what's going to happen when you crank the volume. And I'm going to explain what is happening here in the sound visually with this water. But if you get a larger speaker, you can have a larger speaker and it doesn't need to have as much wattage to produce a louder sound. So you're saving more electricity on a larger speaker and it's producing better sound. And I want to explain that. So if you have a smaller speaker with because in a home, like like this room here that I'm in, I don't have the space to put a large PA speaker in my room. So people think, okay, larger speaker means louder speaker, smaller speaker means quieter speaker, but that's not the case, because like I just said, you can have a small speaker with a lot of, like, it rated for 1500 watt compared to 50 watt or 18 watt, which means it's going to be a very tiny speaker but super loud. That can basically, my neighbors can hear it. So I can have very expensive tiny speakers in my little office room here and have the sound like amazing loud. But the thing is, what's going to happen is if I crank the volume, yes, technically it can produce these larger waves. Okay, you're seeing it. Look at, if I crank the volume and I just pound that little pebble of water, or let's say a rock, into the water, it's going to hit at a very hard impact, right? And with that impact, the harder the impact, the greater the force, the further these ripples are going to go. So yes, technically, you can increase the spectrum of sound that it's able to produce. And this is why you can see that small speakers are able to produce really good sound. Great quality small speakers can produce really good sound to reach further frequency spectrums. And that's why they sound really good. And people think, okay, well, I don't need to go buy a big PA speaker. I can just get a really high quality small speaker, because it's able to produce all this sound waves that a small droplet with a low wattage, like here, this is a low electricity, energy efficient speaker, like a 300 watt or something, stage monitor, is able to produce. And it's limited to this range of frequencies. But if I get a small one with a high wattage, it can produce frequencies way out to here, which sounds, you got more sound, better sound coming out, and it's louder. But look at what happened compared to this other one. You see one problem here. Look at how clean the high frequency is, because it dropped at a low wattage and the volume was halfway and it wasn't cranked up. And look at what happened here when I just pounded the water with that high pressure, high wattage PA speaker. Yes, benefit, yes, I did get all those extra frequencies. But look at what happened here. And look at the waves. If you look at the waves very carefully, you'll see there's distortion. They're not clean anymore. They're a little bit clean out here in the low frequency spectrum. But if you go towards the inside where the most impact was, you'll see that the waves are very distorted. Even if you look in the center, you can't even see the ripple waves until you start getting to the mid frequencies. Then you start to see the waves, but they're a bit distorted, and then they start clearing out as they get further. But near the center, there's a bunch of distortion. So this is why people will say that, like, I don't understand. You know, I bought this PA speaker. It's about $300, and it's no, $400, and it's about a 300 watt stage monitor, and I'm using it in a room. But as soon as we increase the volume, it just becomes noise, and it doesn't sound clean or clear or good quality anymore. What is that? I'm showing you right here. This is what's happening visually in the space of sound in the air, but we don't see the air, right? So this is what's happening. So having a high pressure, high wattage, yes, it's good in a home setting. But when you try to take that and put it in a large room and crank up the volume, so this is why I don't really see a benefit of buying a high wattage small PA speaker compared to buying a large PA speaker, which has the volume capabilities as a small one, but it will also naturally produce bigger ripples because it has a larger drum. And this is what I'm going to show you here in the next slide. This one here, this is a large cooking pot. So you see right down here there's a small little droplet here. But as soon as you drop a pot of water, a cooking pot into the mass of water, you'll see instantly it'll start creating large ripples, which will spread a lot further than something that is producing small ripples trying to spread out. Okay. This is getting very interesting now because there's two topics that we're talking about. And this answers the question why there is generally on middle-sized PA speakers, let me get into it here, and we just looked at it. I'm just reminding you of something that we just looked at. Let me go back here. Back. Now you're seeing. Again, we're looking at why one is small and why one is large. Why is there 2 drums on a speaker? Why is there up to 8 drums? Why is there more than a single drum when the speakers get larger? This is the benefit I'm showing you right now. And there's a reason for it. And that's what I just showed you in this water demonstration. When you look at the small ones, like I just said, they only have a single one. And this one is in comparison to this one. Okay? Now, instead of just getting one that produces 1 ripple of sound, why not get a speaker that produces the large one, just like the pot here, let me go back, produces the large wave for all the lower end frequencies, and then also produces the little droplet of water for the high frequencies. So that way you don't have to crank the volume on the PA speaker, but the speaker naturally, regardless of what volume you put it on, is going to create crisp and clear sound for the top part here, which is the high frequencies, the high sound, which is all the sharp, clear, tinny sound that you're going to hear in a speaker. And then it will also produce all the low end frequency spectrum for all the mids and the lows on the bottom half. So this essentially will give you more headroom, a more wider range, to be able to get all the frequencies in and give them space so that sound will come more clearly rather than trying to cramp everything into a small, narrow, high-pressure hose that will end up distorting the sound and create noise. So we want to create cleaner sound, so we need a larger environment for that sound so they don't conflict with each other. So when it's combined, you're going to hear clear sound, and you're also going to hear the full spectrum of sound. So this is why more drums are important, but sometimes you'll see on a subwoofer they have 2 drums of the same size, but some will have small ones and large ones. So when you're looking at a speaker, you would want to get a speaker that has both small drums and large drums, because that will let you know visually that this PA speaker is able to produce separately the high frequency sounds and separately the large frequency sounds, so that they're all not coming through one, that you have to use one to do something like this right here, that you don't want to be able to have 1 droplet or 1 drum in the speaker produce all those waves of sound and then end up distorting some of them. So this is what we don't want happening. So if you look at here, look at how distorted this is. And this is what happens. You don't even see, like you see if you look back here, yes, I just pounded that rock into the water, just, right? And with that, it distorted the high frequencies and it just became noise. It started clipping and you hear a lot of distortion, but it did produce all those low frequencies way out here. You see the waves out there. But this is not the proper and professional way of producing sound, projecting sound. So we need to understand the PA speakers and what it's designed for. And based on the wattage is important. So with that being said, we talked about wattage. We talked about the size of the drum and the difference of that size and why it's important. And you don't want to use a small drum to try and create large ripples. You want to use a large drum to create the large ripples and a small drum to create the small ripples. So that way none of the ripples are ever going to be distorted. So then what is the importance of wattage? Well, here's the thing. If you're going to get a speaker that has something dedicated to produce the high frequency spectrum, the small ripple, and you have in the same speaker something that produces the large frequency spectrum clean without any distortion, then it gives you more flexibility, which means you need less volume to create cleaner sound. So this is why people have that misunderstanding that, okay, if I buy a large speaker, it's going to be too loud. I don't need it that loud. Well, it doesn't mean larger speakers are louder. It means larger speakers have the capability of going louder, but they produce cleaner sound than smaller speakers. Because smaller speakers, the louder you go, the more it distorts. But the larger speaker gives you that headroom because it supports, it just widens up that area of the frequency spectrum to be able to produce that cleaner sound, and it gives you more room to go louder without distortion. So this is why they say, measure out your room and know the size of your room, because the larger the speaker you go, the more this speaker is able to produce cleaner sound in larger environments. So this is a thing we have to weigh out when we're ever going to set up in a place. How big is the room and what size of PA speaker do I need? But you don't have to really be so critical to say, okay, well, I have to measure my room to know what size of speaker I need to get. If you just go and get a large speaker is able to work in a small room and a large room. So it just eliminates the hassle of you getting something and finding out it's not large enough for the type of room that you're in, and it starts to create distorted audio because the volume is set to a certain limit before it starts distorting. You don't want it too much pressure. You don't want too loud before it distorts. So it's safer to go with a larger PA speaker and have the volume reduced and increase it to your need than just taking the risk of going with a smaller speaker and then trying to increase that to make it adequate for the room. So this is what I wanted to explain in a visual demonstration about PA speakers and how they work and the purpose for that. So also too, when you have the volume increased, the louder the sound pressure decibel is, the further that wave travels, it creates feedback because the waves are traveling, and those waves can come into an input source and be replicated, and then you'll have a loop, which is called feedback. So you want something that is able to produce the right wave of sound that you need without traveling too far, which means that the lower the volume is, the lower the sound pressure is, the lower the wattage is being used, and the more you increase the volume, the higher the wattage is going to be. So the lower the volume, the lower the wattage, the smaller the area is going to be for feedback. That's why it happens when you turn up the volume. All of a sudden, you get this loud screech because you now increased the area, the zone on which the microphone now is picking up those waves to then replicate them and cause feedback. So a lot of people don't understand, why does increasing the volume create feedback? This is why, because you're increasing the distance of the wave being produced. So instead of increasing that distance, why not create the wave that you need with the minimal distance so that it reduces the feedback in the room from all your input sources? So that way you'll have all the waves that you need for all that clean sound without having to, cut corners and end up causing two major issues, which is one, distortion of the wave, and then producing waves that extend further beyond what you want, and then create all these feedback hotspot zones. So thank you for listening. This has been an in-depth explanation regarding PA speakers. Thank you for listening, and we're going to stop for this episode 6.